This is the fourth video of the Unit 2 test review. We're on number 26 here. It says solve y equals x squared minus 2x plus 4 and 2y minus 2x equals 28. Now I can't use matrices because this is a quadratic, so I'm simply going to graph them and see where they cross. But in order to graph this one, I want to get it into y equals form or slope-intercept form. So I'm going to add 2x to the other side to get 2x plus 28. And then I'm going to divide by 2 to get y equals x plus 14. So I need to graph this equation and this equation, and I want to see where they cross. So I'm going to go to my calculator, I'm going to turn it on, I'm going to go to y equals, type in x squared minus 2x plus 4, and x plus 14. And I'm going to hit the graph button. And I want to see where these things cross if I can. Okay, alright, looks like it's crossing outside of my window. So if I hit the window button and I change this y max to something like, I don't know, 50, change the scale to 5, hopefully then I'll be able to see where these things cross. Okay, I can clearly see that it crosses twice, which means it has two solutions. So I'm going to do second trace 5 for intersect, move the spider on top of one of the solutions, hit enter 3 times. One of the two solutions is negative 2, 12, so I'm going to write that down. Negative 2, 12. And the other solution, second trace 5, move the spider over to the other solution, and then I'll hit enter 3 times again. 1, 2, 3. And the other solution is 5, 19. And that is the answer to number 26. It's been solved. All right. So let's look at number 27 here. It looks like it's a word problem. A cashier has 25 coins consisting of quarters, dimes, nickels that total $4.90. If the number of dimes is 1 less than twice the number of nickels, how many quarters, dimes, and nickels does he have? So I always like to start by defining my x, y, and z. Let's say x is the number of nickels, and y is the number of dimes, and then z is the number of quarters. So if I'm going to write an equation, I should probably start with the number of coins that he has total. X plus y plus z, and from the first sentence it says there are 25 of those, so there's 25 coins total. Now the value of a nickel is 5/100ths of a dollar, so 0.05x plus the value of dime, one dime is 1/10 of a dollar, 0.10y plus the value of a quarter is 0.25z equals the total value that he's got, 490. Now these two equations are in standard form. They're ready to be typed into a matrix right as they are. This third equation is the tricky one. If the number of dimes is 1 less than twice the number of nickels, so the number of dimes is 1 less than twice the number of nickels. Okay, so dimes are y, nickels are x, and I need to put this so the number of dimes is 1 less than twice the number of nickels. So twice the number of nickels and 1 less than that is -1 is our third equation. But this is not standard form, so before I can type it into an augmented matrix, I need to go ahead and get it in standard form. And I'm going to do that by subtracting 2x. This will be negative 2x plus y equals -1. So now I can write the matrix 1, 1, 1, 25, 0.05, 0.10, 0.25, and 490. And then this last one's -2, 1, 0, because there's no z, and -1. So I'm going to go to my calculator and I'm going to type it into the matrix. I'm going to go second matrix, edit, make this a 3 by 4 matrix. and I'm simply going to type in the augmented matrix that I just wrote. And I'm going to do that right here. So the augmented matrix I just wrote was 1, 1, 1, 25, 0.05, 0.10, 0.25, 490, negative 2, 1, 0, negative 1. And I'm going to go second matrix over to math, up to B, second matrix A, and hopefully it spits out a solution. 3 nickels, 5 dimes, 17 quarters. So if I wrote down that solution, 3 dimes, 5 nickels, 17 quarters. All right, moving on to number 28. It's a graphing question. A 20-acre orchard is planted with apple and peach trees. At most, $10,000 can be spent on planting costs. Planting costs for apple trees are $200 per acre, and peach trees is $1,000 per acre. The system of inequalities that represents the situation is given below. Graph the system below. Okay, so I'm going to make this my apple axis and my peach axis. So I need to solve these both for peaches. So that means P is less than or equal to negative A plus 20, and 1000 P is less than or equal to negative 200 A plus 10,000. Divide everything by 1,000 to get P is less than or equal to negative 200 over 1,000 would be 2/10 or 1/5 A plus 10. So I need to graph this equation and this equation. And so if I just say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I think I'll be good to go, because this first equation starts at 20, and then it goes down by a slope of 1, so down 1 over 1 every single time. And you can do that as long as the scale on both of the axes is the same. So while I'm doing this, I'm asking myself, am I drawing a solid line or a dashed line? And it's going to be a solid line because of this inequality right there. And you might be asking yourself why I haven't done the negative axes at all. Negative y, negative x, and that's because does it make sense to have a negative peach or a negative apple? I don't think so. Now, we're going to shade that below, but I'm just going to shade the solution set. So let's just remember that this is shaded below. P is less than or equal to negative 1 over 5a plus 10, so I'm going to put a dot at 10, and I'm going to go down 1, right 1, 2, 3, 4, 5, down 1, 1, 2, 3, 4, 5, down 1, 1, 2, 3, 4, 5, down 1, 1, 2, 3, 4, 5. And that's also a solid line. And the question is, we're told to graph the system. Now the solution space is where it's shaded twice. And since they're both less than, this is the solution space right here. And that's my answer. All of the solutions exist in here. It's 29. Let's jump to 30. All right, these last 4 questions are just graphing questions. So I may not have, I only have 6 minutes left. I may not be able to do all 4 of them, but I can at least show you how to do them. So we're just going to graph the system of inequalities, and label the axes in the equations. So check it out. We can draw in our axes here. And, x and y. So this first equation, y equals 3x squared. What I want to do, or sorry, not equal, greater than or equal to 3x squared. What I want to do is type into y equals that same equation, 3x squared. And then I just want to go to the table and steal some points. Second graph. So I see 0, 0. I see 1, 3. I see 2 and 12 I can't make fit. But negative 1, 3 I can make fit. And those are the only things I can see on the graph here. But if I hit graph, I can see that this thing is supposed to be a parabola. So as I'm drawing it, I'm drawing myself a parabola. And I'm making it a solid parabola because it's greater than or equal to. Of course, if it's greater than or equal to, that means I need to shade above. I'm going to leave it unshaded for now because we're looking for the solution space. But just remember that this is supposed to be shaded above. Now if I go to y equals again and type in the second equation, 2x plus 2 times 3x, and go to the table, I can steal some more points. I've still got 0, 0. I've got negative 1, 8, and positive 1, 8. So positive 1, 8 is 1, 2, 3, 4, 5, 6, 7. It's like up here. Negative 1, 8 is like down here. So this line is really, really narrow. So I can just kind of draw it in like this. And it's a solid line. And it's all the stuff that's less than that. So the solution space is right in here. Okay, that's the stuff. That's the solution space. Let's try this next one using the same methodology. We'll start with y equals x times x plus 3. Notice I haven't done any algebra. I'm just typing in it exactly as the equation's given to me. And this looks like, oh, I should draw my axes. And so x plus 3, I'm just going to grab some points here. 0, 0, negative 1, negative 2, 1, 4, and 2, 10 I can't make fit, but negative 2, negative 2, and I think I can get negative 3, 0. And this looks like it's turning into a parabola, but we should hit the graph button just to be sure. Yeah, this thing's definitely a parabola. It's going to look like this. And it's greater than or equal to, so it's a solid line and it's shaded above. Now let's grab the second line. Oh, I forgot to label these. This is a of x. This is my x and y axis as well. And 2 times x plus 2 times x plus 3. Haven't done any algebra, just typing in it exactly as it is. Second table, I'm going to graph some points. 0, 6, 1, 2, 3, 4, 5, 6. Negative 1, 2. Negative 2. Negative 2. And negative 3. Negative 6. So it looks like I can draw this line in. It's going to be a solid line that is shaded below. So if I shade above the parabola but below the line, this is the solution space. It's very similar to the last one. And label your line as P of X, sorry. And it looks like I've got time to do one more, so let's see if I can do it before I run out of time. X times x plus 3 is the equation that I just graphed on the other one, so I can actually just steal those same points from the previous one, which I'm going to do really quickly. I'm just copying a of x from the previous graph. 4 and parabola. But this time it's less than, so it's all the stuff below that parabola. It's the same line here, the same line that we just did above, except this time it is, well, it's also shaded below. So all the stuff that's shaded below both lines is all this stuff. So that's the solution space that time. I don't have time to do number 32, but if you check the answer key on the calendar, you'll be able to see my solution. Thank you for watching.